so let's continue with integration by part. So last time, well, after covering the first few pages, we work on additional examples on the board, and then I mentioned we should do this after, well, to like open the day. So let's see. So we're given this formula right here, x to the n cosine ax, and well, we're given the result of that formula. So in this case, they're asking us two questions. Letter A. Use integration by parts to derive this formula. Of course, in this case, notice this one doesn't have any numbers at all. It's all symbols. So what we're going to do, okay, so that's the integral of x to the n cosine ax, which is something we have already done with numbers, where n was a number and a was also a given number. And in this case, well, we need to set up the parts. Well, to set up the parts, again, we rely on the LIATE acronym here. All right, so let's start with the L. L, logarithmic functions. Do we have any? No. I, that's for inverse trigonometric functions. Do we have any? No. A, algebraic functions. Do we have? Yes, that's the x to the n. So that's the u equals x to the n. Well, and the dv would be the remaining part, that is cosine ax dx. Okay, so what's the derivative of u in this case?
Nx n minus 1.
Mm-hmm. N times x to the n minus 1, subtract 1 to the exponent, multiply by the old exponent, and the integral of cosine.
1 over a sine ax.
Perfect. Alright, so we have all the information that we need. Oh, don't forget the dx here. Alright, so let's see. So using the integration by parts formula, let me write it down at the top again. The integral of u dv equals the u times v minus the integral of v du. Alright, where u is x to the n, v is the 1 over a sine ax. Let's multiply that. X to the n times 1 over a sine ax minus the integral of v, which is 1 over a sine ax du, which is n x to the n minus 1 dx. Alright, let's simplify this a little bit. There's really not that much to simplify if you ask. Well, so let's put together this x to the n sine ax over a. That's the first term in the formula that we were given, isn't it? So score, let's check for that. Let me make this a look like an a, look like a 9. Minus, okay, I'm going to take out of the integral all these constants in this case, this n and this a. And over a, integral of x to the n minus 1 sine ax dx. And isn't it the formula that we were given? Alright, so we used integration by parts to derive this formula. For letter B, by the way, for whatever reason the integral didn't show, so apply this formula to the evaluation of the integral. Let me write it down. The integral of x cosine 2x dx. All right. So let's see. The number one thing that we might want to identify first is, well, in this case, what's n?
1.
N equals 1. It's an invisible 1 here. And what's a?
1.
That's a 2 in this case, right? So let's just use the formula here. So the integral of x cosine 2x, number 1, let me write down the formula again, the formula that we just wrote. or if we just derive, integral of x to the n cosine ax dx equals x to the n sine ax over a minus n over a integral x to the n minus 1 sine. So we're going to apply this formula to this given problem. All right. Well, so this will be x to the n, that is x to the n, which equals to 1. I'm going to write that 1 just because, and sine ax, which in this case is a 2x, and then divide the whole thing by a, which happens to be a 2, minus n, which equals to 1, over a, which equals to 2, integral of x to the n, which is 1, minus the 1 from the formula, sine 2x dx. Well, we can simplify the first term by just erasing that 1, that invisible 1, that's x sine 2x over 2 minus 1/2. Okay, so what's going to happen here? This x to the 1 minus 1, that's going to be an x to the 0, which reduces to 1. Okay, and 1 times sine, that's simply sine, right? So 1/2 sine 2x dx. And well, this integral is one of those really simple ones that you don't have to show the whole u to u setup. X sine 2x minus 1/2, that multiplies the 1/2, that's a 1/4 cosine 2x plus c. And I made a mistake on purpose here, so I can see to see if you can catch it.
Positive.
It's positive, right? And that's because the integral of sine is negative cosine times the negative here. That should turn into a plus. All right? Sounds good? So